Thanks, everyone. Once again, my name is Travis Spencer. I'm the CEO and founder of a company called Twobo Technologies, as well as Nordic APIs. And Twobo Technologies, for those of you who don't know, is an API security company. And that's really what I want to talk with you about today. I want to dive into some of the nuts and bolts and the fundamentals, and as much as I can fit into the 30 minutes that I have. And actually, it won't be that hard, because the problem's solved. We have API keys. Right? Done. So yes, thank you very much. Your problems are solved. But the problem with API keys is kind of like with this lock and with this key. I mean, if I have this lock and I can open it with this key, like an API provider, if I give this gentleman here the key, and you then could unlock this key or this lock just like I did, but you could also give that key to this fellow, or this fellow could actually tackle you and take that key, right? And then when he presents that and actually tries to unlock this lock, does it work? Can you unlock that?
Yes.
You can.
Yes.
And I, as the API provider, don't know that it was you and not you who opened it, right? So the key itself is not providing us with enough information to make a proper decision about whether or not you should be allowed to open this key. So really what API keys are is revocable, non-expiring bearer tokens. If that doesn't make sense, think of them as symmetric keys. And all of the associated problems that you have with symmetric keys, of exchanging them, of revoking them, managing them. And if that doesn't help, think of them as passwords. How hard is it for you in your life to manage all of your passwords? Hopefully you've got some sort of password manager. Those, of course, come with issues. But it's a big job. And here we are in the API space. Do we want to start where we kind of have left off and just perpetuate the problem? Or should we find new ways, new technologies, new techniques to address these and overcome these challenges? And I say that we should solve it a better way. And of course, we use API keys, we use symmetric keys in some scenarios that make sense. But in other cases, they don't. So don't worry, problem solved. I've got the solution right here in this box. All I have to do is open it. It's OAuth, right? You always hear this. If we just do OAuth, then we'll have secure APIs. But this box is empty. You can't just go and get an API security solution out of the box. It's not going to work. You can't just download the PDF of the API or the OAuth specification and boom, your API is secure. That's not how it works. There's a lot in that box. You have to unpack it, and that's what we're going to get into today is, what is in OAuth and what is the other parts of API security that we should be thinking about. Because really what we want to do is create a holistic approach to API security. We need to be thinking about not only the API security, but the enterprise security. We need to keep our servers safe. We need to have processes, procedures for managing our computers, as well as the endpoints like the mobiles on which our apps are running, the servers on which our cloud services are running. We need to have a holistic end-to-end approach, and we're going to be attacked on all three of these fronts if we have data that's worth anything. So we need to have this comprehensive approach to securing our systems and our data, and really where it starts is identity. At the heart of all of those three concerns is knowing who somebody is. Just like in the key scenario, I didn't really know who you were. You held the key, you presented it. We need a solution where we can represent people encoded in digital form. And we can do this with tokens. We can do this with OAuth. But it's not enough even with OAuth. A lot of the impediments that were holding organizations back in adopting a RESTful approach to APIs was the lack of standards for providing security. Thankfully, that problem is gone. We have great standards now, better than the ones we had in the SOA days, where we can actually create secure APIs, where we can do authentication, where we can do authorization, where we can do federation. And these are coming to us with standards, not just OAuth. It's not just I open the box and boom, my APIs are solved. We need more than that. We need to be able to do federation so that we can do web single sign-on using a standard called OpenID Connect. We need a way of encoding digital identity. It's all about who you are, right? So we want to represent that in a way that is easy to consume. JSON makes for a perfect technology for doing this. Very low technology stack. We have an encoder in pretty much every language, so using JSON really helps with that. We need provisioning, be able to create users, add users, groups, all of this stuff with SCIM, and authentication using U2F. And in all of it, we need to make authorization And for that, we suggest alpha. I don't have time to go into all of these standards today, but I am going to delve into OAuth, and some of the other speakers are going to look at applying those to different scenarios and delve deeper. I'll also discuss OpenID Connect a little bit at the end. So let me start now with OAuth 2. OAuth 2 is sort of a meta protocol, or a protocol of protocols. It's a framework that we can use to build these other standards on top of. Other standards like OpenID Connect, but others like UMA and NAPS are also building on top of OAuth, and more are coming. And really what it's providing is the base, or a substrate on which we can solve other related API security problems. So that's where we want to begin providing security, but definitely not where we want to end. It addresses some really important concerns. The password sharing problem, which we saw with the key and the lock analogy. So you can't just share your key around in the same way. Instead, what we do is we delegate access. So we have encoded in the protocol a way of doing delegation where we almost can't do it wrong. If you tried to do this in the SOA days with WS star specifications, that was super, super hard. And many people did it wrong. With OAuth, we also have the possibility of revoking access, right? If I wanted to use a different key here, what do I have to do? I have to be a locksmith and know how to change this lock. That doesn't work. We need a better way to revoke access besides just changing the keys, changing the passwords. We need to have a way of saying with this specific application should no longer be able to do these specific things anymore. So we need more controls, and that's why API keys. That's why other ways of providing API security are not enough. So in OAuth, there are 4 actors that you need to know about. The first is what's called the resource owner. This is like the end user. There's the client. The client will be some sort of mobile application. It could also be a web application running on a server. And then you'll have the authorization server. This is also called a security token service more generally, and this is in charge of actually issuing the tokens, signing tokens, things like this. And the tokens are presented to the resource server, or the API. So those are the 4 actors involved in the sort of dance, if you will, of APIs using OAuth. To the end user, what this looks like is you'll have some sort of mobile application, and in that application you'll have some sort of button. And it might be a login button, but oftentimes it's not. It's after you've logged into this application, you want to authorize it to do something on your behalf. So it's actually more of like, okay, do you want this thing to begin using data from this third party or something like that? Then you click an authorize button or a connect button, or perhaps if it's provided by the same company as the API, an authenticate button. And then there at the OAuth server, what you're going to see typically is some sort of, how do you want to log in, but not necessarily. And some way of collecting a credential. It could be username, password. It could be other things, though, like a 2-factor that was sent over SMS challenge or something like that. And then finally, you'll see a consent screen where you're being asked, do you want to authorize this application to do things on your behalf? Do you want it to actually consume your data while you're using the application? All of those screens are actually optional. Depending on your use cases, you may or may not see them. You may have actually agreed to and consented to that application doing those things as a part of its end user license agreement or your employment contract or what have you. So under the covers, though, what's happening is, first of all, that this client is accessing the OAuth authorization server. And that puts up that login screen. The specification says you must log in. It doesn't say how. It just says that you must. And so you put in some sort of credential, and what you get back is a code. And this code is a one-time usage token, a nonce. And this nonce comes back to the client. And the client then uses an API key, actually, a symmetric key or an asymmetric certificate to send that up and identify itself so that the OAuth server will know who it's communicating with. And then the OAuth server will respond with an access token and potentially a refresh token, and it will use the access token to call the API. In OAuth, there are different flows. This is a very common flow called the web server flow. There are others like the implicit flow and the client credential flow, resource owner credential flow, but I don't have time to go into those. But after the access token is presented to the resource server, depending on the type of token, and I'll get on into that, the token might be validated with the OAuth server. And in any case, the data will be returned based on the identity of the end user, based on the delegate, the mobile application or the client application. So those things can be accounted for and used in the decision of whether or not data should be returned. OAuth also defines something called scopes. Scopes are like permissions. You may have seen these before in user interface screens like this, where as a delegator, you're asking, being asked the question, do you want to allow this application or this delegatee to do things on your behalf? There's no standard scopes in OAuth, but this is actually a good thing. So you have lots of flexibility of modeling the permissions and the delegations that you are having in your system. I mentioned briefly in that flow access tokens and refresh tokens. These are two kinds of tokens that you're going to be dealing with as you implement OAuth. Think of an access token like a session, and think of a refresh token like a password. So if you go to a mobile application and you need to bootstrap a session, you're going to do that with some sort of password or some sort of long-lived credential. You can do that with a refresh token, and this can be used to get you new temporary sessions or access tokens. And by having those two sort of kinds of tokens, we can start to do all sorts of interesting use cases where we could create almost like the same sort of experience you might have on an insurance company's website or a banking website, or those where you have rolling sessions. We can start to do those sort of things with OAuth, with these types of tokens, which we can't do with other solutions like API keys. There's also different profiles of tokens. We have bearer tokens and holder of key tokens. There are others, but these are the only ones I'm going to talk about because these are the only ones that are really used. Think of a bearer token like cash. If you find some Danish kroner outside on the street as a bill, you can actually take that and go into a shop and spend it. And the clerk is not going to ask you for any sort of proof or information about how you got it. You found it on the ground, you can spend it. In the same way, bearer tokens, anybody who has them can use them. Even like with the key example, right? You had the key, you could use the key. It's a bearer token. Holder of key, on the other hand, ties the token to the one who the token was issued for. So in using that analogy of money, it's more like a credit card. Like when you go into the shop and you present your credit card, the clerk will ask you for some form of identification to make sure that the one who was issued the credit card is the one presenting the credit card. So we have both of those flavors or profiles of tokens that we can use in OAuth. There are different types of tokens as well. The specification doesn't say anything about the sort of types of tokens that an OAuth server needs to issue. OAuth server can issue many different sorts or types of tokens depending on the use case, the clients, the flows, the scenarios. And this gives you a lot of flexibility for dealing with some of those interoperability issues where maybe you have some legacy systems in the back that need some of these older formats of tokens. So we can take care of things like SiteMinder and Oracle as well as WS Security and many others. But these days, more and more, what you're finding is something called JSON Web Tokens that OAuth servers are issuing. A JSON Web Token, pronounced like the English word jot, or to write something quickly, is a lightweight token that's intended to be passed in HTTP headers and query strings. So this format was created specifically for this intention and being used on mobile devices and low bandwidth scenarios. So it's extremely compact, and every single byte in the entire packet is thrown out that can be. So they're very similar to what you could do with SAML or other sorts of tokens, but designed to be used in modern scenarios where mobile is a big part of it. It's not as expressive as some types of tokens like SAML, but by being based on JSON, we have that advantage of being able to use all sorts of different parsers and technologies because we have the implementations of JSON in those languages and frameworks. We also have the ability to pass tokens in different ways. So because the OAuth specification doesn't say anything about what's in a token, we can actually create what's called a by value and a by reference token. So a jot is an example of a by value token. And what I mean by that is analogous to the way in which we're passing data around as programmers and developers. When you pass something by value, you take the entire data and you push it on the stack as you call a function. By reference, however, is you just pass a pointer to that data. So with a token, you can actually not put any identity data in there, but instead have some sort of random string and point to that identity data so that the receiver of that data can dereference it and get that entire identity data. And this is useful in different scenarios. I'll get into that in a little bit. So as I said, we can't just open this box and have OAuth to solve all of our problems. We need to know where it's useful for, how to use it. We need to be looking at some of these different things like kinds of tokens and types of tokens, and keeping in mind, that API security and OAuth are just part of a larger problem, creating a holistic, comprehensive system and approach to solving and protecting our data. And so we need to use OAuth appropriately. And OAuth, despite the name, doesn't actually help with authentication. Authentication is about figuring out who somebody is. It's about identifying someone. It's about comparing something with something that's presented to you to respond to a challenge, to figure out if that person is who they claim they are. So OAuth is not helping us with that problem, and in fact the specification completely punts or gives up on that and says it must be done, but not how. So it's not for authentication, and it's also not for federation. So federation is all about taking the answer to that question of who you are and reusing it in some other security domain. OAuth does not help us with that problem. Neither does it help with authorization. It's actually not about figuring out what someone is allowed to do. What OAuth is about is delegated access. You can do things on my behalf. And this is more of a semantics, but it's an important one. This is an important detail to get right. Otherwise, you could be using OAuth in an improper way that opens you up to security vulnerabilities. And even organizations as big as Facebook have fallen into this trap. So to understand the semantics and the nuances, what I mean here is this is comparable to, say, a business owner who would like to have help from an assistant to manage the business's accounts. And the business owner delegates to that accountant the right to pull money, to withdraw money out of the business's bank account. And when the assistant gets to the bank and tries to use that new right that has been delegated to the assistant, the bank would say, no, you're not allowed actually to take any money out of the account. Why is that? The business owner delegated that person to have that right. The reason is because it was delegation and not authorization. The bank has rules and procedures about who should be allowed to take money out of a bank and who shouldn't be. And if those proper rules aren't followed, the bank will deny the access. It's the same here with APIs. We can use OAuth to actually say, you can do things on my behalf in this application, but then when presented to the API decides, that doesn't matter to me what the person has said. You can't do these things. Or, yeah, that's good enough for me. You're authorized. So it's a distinction and a sort of a semantics, but it's an important one to keep in mind as you're implementing these standards. So as I mentioned, OAuth is being built upon by other standards. And one really important one that you guys need to be aware of is OpenID Connect. This is a next generation protocol for solving federation and web single sign-on. It's based on OAuth 2, and as with OAuth 2, it's mobile first. So it's designed to work in mobile devices and mobile scenarios. It's not backward compatible with the previous versions you guys have heard about before. So those versions of the protocol were mostly designed for low risk or low value data. And OpenID Connect is actually a complete rewrite, a sort of version 3 of the protocol that is designed to have parity with other federation standards like SAML. The client and the API are both receiving tokens in this, and I'll explain that. And it's also providing a novelty called the user info endpoint for getting additional information about an end user using a standard API. So let's look at that flow. As I said, it builds on OAuth, so it starts in the same sort of way, where a client, or as OpenID calls it, a relying party, will make a request over to the OAuth server, which has an extra name in OpenID Connect called an OpenID provider. And what it sends in this request is the normal OAuth stuff in addition to a scope called OpenID. And that clicks the OAuth server into OpenID Connect mode. So as before, the user will authenticate by hook or by crook, doesn't matter how. and an access code, that one-time nonce or one-time token, will be sent back to the client. The client then will use its credential, symmetric or asymmetric, to send that code over to the OAuth server, and now that code has been used up. It can no longer be used again. But what comes back is the access token, potentially a refresh token, and this new kind of token, an ID token. This ID token has information about who the user is, how they authenticated, when they authenticated, and any sort of additional claims that the OAuth server wants to put in there. This is really useful because this ID token is meant for the client. In the previous scenario, the tokens were all sent to the API. So the client had no way of knowing anything about the user. What if the client, the web application, wants to sort of personalize the experience? It had no information in that access token to be able to do that. And now using OpenID Connect, we can solve that problem. So a lot of times what's happening with OpenID Connect is it's being used for authentication even, not just federation. A lot of people are using this for connecting internal web applications to each other to gain single sign-on and to have information in each of them about the end user. So that to do that and ensure that the token is issued to the relying party, what it will do is check the audience. The audience is almost like, think of a gift certificate. If you find a gift certificate or you get a gift certificate for Christmas for Starbucks and you take that gift certificate to Espresso House, the guys at Espresso House are going to look at you a little funny like, this doesn't work here. It's the same with ID tokens. They're audienced to say that this is for Starbucks and not for Espresso House. So these are the sort of things that we can do with tokens that we can't do with simpler systems. Now that we have an access token and that ID token, one of the things we can do with the access token is to call this standardized API that OpenID Connect defines, called the user info endpoint. This can be used to call the OAuth server to get additional user information like shoe size, hair color, anything about the user you could think of, and that makes sense in the system. But you can also get additional tokens. So you could actually use OpenID Connect to get additional tokens, and Jakob in his upcoming talk will explain some different interesting scenarios for doing that. So the user info comes back to the client, and now it could have additional tokens to make API calls of all sorts. So as I said, the ID token is intended for the client, and it's providing not only information so that the relying party can know it's for it, but it can also look at username, credentials that were used, things like that. So the user info endpoint, also useful for discovery, so learning new things about different APIs to call. Here the subclaim must match the claim in the ID token. Some details about the standard. One of the things that we see as we go and talk to our customers is that more and more of them are adopting microservices. I imagine that many of you are as well. I met with a customer a few weeks ago who said across their entire organization they were building on average one microservice per day, and this was from a gigantic bank. So if they're building a microservice a day, I can imagine some smaller organizations are creating more than that. And we heard about some of the reasons for that, not forcing developers into a certain technology, having different possibilities, trying things rapidly, all sorts of different scenarios for using microservices. But in that, it presents some challenges of how do you secure all of these. So I want to look at how you can apply some of these things to microservices. We talked about JOTs. We talked about how in a JOT you have all of the identity data about who the user is, how they authenticated, things like that. If you call an API that is a microservice and you include in that JOT token everything about the end user, the microservice will not have to do any authentication, any sort of figuring out who the end user is. It will just take that data, check a signature that's over the JOT, and be able to know that that end user is who they say they are. But what you want to do, and what I recommend you consider doing, is to actually use some sort of reverse proxy or API firewall where on the outside of your network it's a reference token. And as the token flows in, translate that into a by value token, passing it into all of your different microservices. So your microservices end up trusting your your OAuth authorization server that you have locally. You can verify that that trust using asymmetric cryptography or even symmetric if you wanted. And as tokens are flowing into your network, you're going to translate them. Consequently, all of that identity data, it never leaves your network. And this is happening quickly and being cached in the API proxy. So more to say, much more to say. Unfortunately, I don't have time, only a minute or two left. But I wanted to leave you with some references. So snap a picture of that real quick. There's some really good blog posts on the Nordic APIs website. We are also going to produce a post about API keys in the next few weeks. This should be pretty interesting. There's some videos there, and out here on the table is a white paper that explains some of these things, and we're also planning to publish an API security ebook in the next few months on the Nordic APIs website and the Twobo website. So just to summarize real quick, got all your pictures? API security is more than about API keys. API keys don't provide us with enough information to figure out who the user is on the other end in many scenarios. So we want to use OAuth, but we need to use it in different ways and in different scenarios. So there's different token types that allow us to do different things. There's different profiles of tokens. There's different ways of passing tokens. And we can use those different capabilities in scenarios like microservices or an internal web single sign-on and things like that. So we want to be using things like OpenID Connect to solve those internal use cases, but also others, and sort of starting with OAuth and OpenID Connect and then building on top of that with other standards that I didn't have time to go into. So with that, I'd like to thank you for your time and appreciate you coming. And if I can answer a question in a minute or two, I will. Otherwise, I'll be around during the break.